All right, notes from March 3rd, part 2. Okay. I wanted you to take a guess at what the words mean. Figure out for yourself. Try that out. So endo, if we go back up here, we're saying that it's inner, absorbing. That's a really big one, right? So I'm going to stay with that. I have going in, absorbing, and thermic means heat. Exo, on the other hand, exiting, right? The heat is exiting. It's leaving. It's going out. Endo, heat is going in. Exo, heat is going out. Okay. And the textbook definitions you should have from the slides. There you go, right? Copy those down. In a written chemical equation, right? So if I have endothermic, heat is going into something. It's going into the thing. It would be on the left side, right? Because think about you're putting ingredients into a cake. Put the cake into the oven. Out pops a cake. So heat, right, we'll put A, B, C, whatever. Doesn't matter what those letters are, just, saying that there are other things in the chemical equation, like chemicals. All right, exothermic, right? So if it's going in on the left-hand side, coming out would be on the right-hand side. And we'll just put X, Y, Z. So the point is, if you see heat on the right-hand side, exothermic, it's exiting the chemical reaction. If you have endothermic, it's going into the chemical reaction. Okay, so these are some examples, right? You have the answers to those. Just take take a note of any of these that you want me to explain during extra help, but you do have the answers. Actually, I think I basically explained all these already, right? Just ask me if you want to go over them again. Okay. So now we're going to go back to the chart. Now let's go back to the slide. Okay. So these are melting, sublimating, vaporizing, right? If I'm going to keep going back to the ice cube in the pan situation. If I take an ice cube, right, in order to get it to be a liquid, I have to turn the heat on to the stove, right? So these are going, and if I'm putting heat into it, right, into endo, these ones are going to be endothermic. On the flip side, right, heat is going to be exiting, right? A liquid has more heat than a solid, right? So I would have to take some of the heat out of a liquid in order to get it to be a solid. So the heat would have to exit. So these processes would be exothermic. Okay. Where am I going? Okay. So now these ones. We're getting back to those heating and cooling curves. For point A, the time, right? I have the time down here, and I have the temperature over there. Time for point A we're looking at here, right? And I'm going to go down. It looks like these are 1 minute intervals, so this would be like 30 seconds. Okay, and then we're looking at the temperature now. Go over here. It looks like these are by 20s, so this would be about 10 degrees Celsius. Okay, so for point B, we're going to do the same thing, right? We're going to go down 3 minutes. Temperature, we're going to go over. It looks like it's 50. Great. Okay, so as time goes on, is the temperature increasing or decreasing? And time, right, as time goes on, we're going this way. temperature is going from 10 degrees Celsius up to 50 degrees Celsius. So it is increasing the temperature. So if I'm increasing the temperature, is it being heated or is it being cooled? Heated, right? I'm adding heat to it. So I would call this a heating curve, right? It's a curve showing that something is being heated, that the temperature is increasing. And that would be your answer to number 5. Oh, wait, no. Number 6 is talking about the one down here. My bad. Okay. So on the flip side, and I keep saying on the flip side because these are opposites, right? Heating, cooling, when you're adding heat, when you're subtracting heat. This would be a cooling curve. And why is that? Because you are cooling the substance. Okay. So labeling the slanted lines, right? So if I'm going back to what I said before about a gas having more energy, right? When I'm saying hotter, I'm saying the temperature is higher. So I'm saying that the particles have more energy. That's a big thing. I'm saying that a gas is hotter, it has more energy than a liquid, and a liquid is going to have more energy, hotter, higher temperature than a solid. So based off that, I can assume that this would be the solid, this would be the liquid, and that would be the gas. All right, great. And we are finished with the March 3rd notes. Next up, we're going to be doing the March 5th notes. And if you remember, we had off on March 4th because of